Hi, and welcome to Calculus Examples. I'm Dr. Finch. Today we're going to be looking for the points on the curve y is equal to x cubed minus 3x plus 1, where the tangent line is horizontal. Okay, so let's start off with remembering horizontal is the way we sleep. So horizontal looks like this. And what that tells us is that the slope of our function has to be 0. And remember, slope is a fancy pants words for derivative. So this tells us that the function that we're working with, we want our derivative to be equal to 0. All right, I'm going to start off by rewriting our function in terms of f of x instead of y. It's a minor thing, but it kind of helps. I don't know, it's just kind of nice. We're going to take the derivative of that function. So we're going to look for f prime of x. We're going to use the power rule. So we're going to take our power down, subtract 1 to get our new power. In our second term, our exponent is 1. So when we bring it down, 3 times 1 is 1. And when we subtract 1, we get x to the 0th power, which is going to be 1. X to the 0 is 1. So this term here disappears. And the derivative of our constant is 0, so that term is going to disappear as well. And we end up with this as our derivative, 3x squared minus 3. And what we're going to do is we're going to set that equal to 0 because we need our derivative to be equal to 0 for our tangent line to be horizontal. All right, so once that happens, the next step that we're going to do is we are going to solve for where this occurs. So we're going to set that equal to 0. We're going to solve. Let's pull a copy of 3 out. Minus 1 is equal to 0. There we go. And normally what we do is we break apart that quadratic that we've got, that x squared. You can do that in plenty of ways. You can use the quadratic formula. You can factor it, and factoring it actually is going to be a lot quicker. I'm going to put something in there which I'm going to write as recall, but you may or may not know this. And so I'm going to write this as a squared. And I just want to show this to you because it's a super useful tool to have. If we have an x squared minus a squared, this only works for minus, we can break that into x plus a, x minus a every single time, right? Because our middle terms are going to cancel out when you multiply that through. So you'll see that those are the same things if you work it out. In this case, our a would be 1. So we can break this into x plus 1, x minus 1 is equal to 0. And when we have multiple things that we're multiplying to get 0, that means one of those things that we multiplied has to be 0 to begin with. Well, 3 we can just ignore because it's never 0. And if you feel uncomfortable about it, you can divide both sides by 3, get rid of the 3 there that way. We are going to start off with our x plus 1 is equal to 0, which will give us the solution x minus 1. And then our second solution will be x is equal to positive 1. So in fact, there are 2 places where the slope is going to be 0, where our derivative is 0. But let's go back up to our problem because we'll notice we're asked to find the points on the curve. And this is important if you're taking an exam in particular, but also when you're doing your homework. Go back and look at the question itself and see, did I answer the question completely? Because sometimes you get through and you get your derivative and you solve it and you feel as successful. And then there's a second part to it that we have to go through that's actually pretty quick. It's just a matter of actually going through and doing that little extra step. And we want to make sure we don't lose any information here. Okay, so we got 2 points that are going to be our solutions. Let's just write those out. -1, and then we have -1 cubed minus 3 times -1 plus 1. And 1 cubed minus 3 times a positive 1 plus 1. And I'm just going to do this in a couple different steps. Negative 1 cubed, that's 3 negative signs, so that is going to be a negative 1 when we multiply that out. Double negative for our second term turns into a positive 1. And the second point is a lot quicker and easier. So we have our negative 1 and a positive 1 cancel. And over here we have positive 2 and a negative 3. So this is going to be a negative 1. So here are the points. There are two places on our function where we have a horizontal tangent line. All right. Thank you so much for listening.